Hello children and welcome to your channel Sharda Educare. Solved example 4th of before 5.1 exercise. What does the sum say children? We have to show that point P, Q, R, S are the vertices of a square. If we are able to prove that it is a square, that means P, Q, R, S will be the vertices of a square. The characteristic of a square is what? All the sides are equal. That means PQ equal to QR equal to SR equal to PS. If these all three sides are equal, then we can say these are the sides of square. And another characteristic of a square is what? Diagonals have to be equal. What is a diagonal? PR equal to SQ. We need to prove this. And if we can prove this, then we can say that 1, 7, 4, 2, minus 1, 1 and minus 4 and 4 are the vertices of a square. Let us prove it by distance formula children. So by using distance formula, this is very important to mention children that how you are proving it by distance formula. So before that I must assume it x1 y1, x2 y2, x3 y3, so that it becomes easy for you to place the points coordinate, and x4 y4 if you are finding the length of the sides. See PQ, distance between the point P and Q, if you are finding by distance formula you can use these coordinates. So PQ is equal to under the root x2 minus x1 the whole square plus y2 minus y1 the whole square. Now we will be placing the value children. X2 is 4 minus 1 the whole square plus y2 is 2 minus y1 is 7 the whole square. We will be getting 4 minus 1 3 the whole square plus 2 minus 1 minus 7 minus 5 the whole square. Sign of the greater number. 7 is greater and sign of 7 is minus. So minus equal to 3 square is 9 plus 25, which is equal to under root 34. 25 plus 9 is under root 34. So we got PQ as under root 34. So let me write here PQ 34. Now we will find out QR. So let me begin here. QR again by distance formula children. So Q and R, these are the 2 points. So x3 minus x2 now. It will be x3 minus x2 the whole square plus y3 is y3 minus y2 the whole square. See, x3 minus x2 the whole square, y3 minus y2 the whole square. Now we will place the value of the coordinate. x3 is what? Minus 1 minus x2. x2 is 4 the whole square plus y3 is minus 1 minus y2. y2 is 2 the whole square. Now we will go further here. So QR is equal to minus 1 and minus 4 will be minus 5 the whole square plus minus 1 minus 2 minus 3 the whole square, which is equal to minus 5 is 25 minus 3 is 9, which will be under root 34. So QR is also equal to under root 34. So we got QR under root 34. Similarly, we will find out SR by distance formula children now. SR. SR. So x4 minus x3 children now. x4 minus x3 the whole square plus y4 minus y3 the whole square. What are we getting now? x4 is what? Minus 4. Then minus x3 is what? Minus 1 square bracket plus y4 is what? 4 minus y3 is what? minus 1 the whole square. What are we getting? Minus 4 minus minus plus 1 the whole square plus 4 minus minus will become plus 1 the whole square, which will be equal to minus 4 plus 1 is minus 3 the whole square plus 5 the whole square, because 4 plus 1 is 5, and which is equal to minus 3 square is 9 plus 25, and we are again getting under root 34. So SR also we got under root 34. I am writing here in the diagram. Now we will find out PS. Let me rub this, children. Now we will find PS by distance formula, children. PS, P and S. So where is P? This, and S is minus 4 and 4. So this point and this point. So x4 minus x1, children. x4 minus x1 the whole square plus y4 minus y1 the whole square. Now place the value of x4. x4 is how much? Minus 4. And then minus x1 1 the whole square plus y4 is 4 minus y1 is 7 the whole square, and we will get, now minus 4 minus 1 is minus 5 the whole square plus 4 minus 7 is minus 3 the whole square, sign of greater number, children. So here minus 5 the whole square is 25 plus 9, which is equal to 34 under root. So even PS we got as under root 34. Let me write it here. PS is under root 34. So we got PQ is equal to QR equal to SR equal to PS. So this we have got by solving this. Now we need to prove PR is equal to XQ. PR is what? Diagonal, and SQ is again a diagonal. You can see in the diagram PR is diagonal, SQ. So let us find out PR and SQ. By again distance formula we can find it out. Let me take the duster, children. So you can pause, children, and you can find out, you can write it down. Let us find PR and SQ. So PR by distance formula, let me write here, PR by distance formula, P and R. What is P? X1, and R? X3. So we need to discuss these 2 points. P and R. X3 minus X1. X3 minus X1 the whole square plus Y3 minus Y1 the whole square. What are we getting now? X3 value is minus 1 minus X1 is 1 the whole square plus Y3 is minus 1 minus Y1 is 7 the whole square. Then we will be getting minus 1 minus 2 the whole square plus minus 1 minus 7 is minus 8 the whole square. Both are minus, so added, and therefore minus sign. Both are minus, added, and minus sign. So what are we getting now here? Minus 2 the whole square is 4, minus 8 the whole square is 64, which is equal to under root 68. So we got PR as 68. Let us go for SQ. Now for SQ is equal to, by distance formula, now where is S and where is Q? Let us rub. This is S and this is Q. So we need to X4 minus X2 the whole square plus Y4 minus Y2 the whole square, and what we will get? Place the values now. X4 is how much? Minus 4 minus X2 is how much? 4 the whole square plus Y4 is how much? 4 minus Y2 is how much? 2 the whole square. Now minus 4 minus 8 the whole square plus 2 the whole square, which is equal to, now minus 8 the whole square is 64 and 2 square is 4, which is equal to under root 68. So even SQ, now look at this, PR is under root 68 and SQ is also under root 68. So we got PR as equal to SQ. So from first and second we can say that P, Q, R, S are the vertices of a square. It satisfied all the condition. So here we can say point P, point Q, point R and point S are vertices of square. How did we get? From 1 and 2. From 1 and 2. Hence proved, children. You can pause and you can solve this. Now solved example 5 before practice set 5.1. What does the sum say? Find the coordinate of a point on y-axis. The point is on y-axis. This is y-axis and the point is on y-axis. Now that point is equidistant, means at equal distance. At equal distance from which M and N. So suppose if the point is here somewhere and point M is minus 5 minus 2. Minus 5 minus 2 will be somewhere here. Minus 5 means somewhere here M and 3, 2. 3, 1, 2, 3. 3 and this is 2. 3 and 1, 2. So somewhere here it will be this point. So point M will be in the third quadrant and point N will be in the first quadrant, second quadrant. First, second, third, fourth. This is first quadrant, this is second and this is third and this is fourth quadrant. So we want to find out the coordinate of the point P, which is on y-axis and which is at equal distance, from point M and point N. So this line and this line, suppose the point is somewhere here. So this line and this line, or this point is somewhere here. Okay. So if the point, let us say that the point P is on y-axis and point P is on the y-axis, it is there. Let us say, let point P be on y-axis. So if point P is on y-axis, its x coordinate will be 0, children, because the point P is on y-axis and the point is on x-axis, its y coordinate will be 0. So let us say x coordinate is 0 and y coordinate, let it be A. So we need to find out A point, coordinate A value. And we know the point P is at equal distance. Equal distance means this length is equal to this length. From point M and point N, means this length is equal to this length. So we can do it. Point P is on equal distance from M and N. It is given. Therefore, PM is equal to PN. We can say it is given. And how do we get PM? By distance formula. So by distance formula, PM value, coordinate P is having 0A value and M is having minus 5 minus 2, minus 5 and minus 2, and N is having 3, 2, 3, 2. So by distance formula PM we can find out under root PM. PM is what? x1 minus x the whole square plus y1 minus y the whole square. y1 minus y the whole square is equal to, now x2 minus x the whole square, x2 minus x the whole square plus y2 minus y1 the y the whole square, y2 minus y the whole square. Now we will place the value, children, under the root x1. x1 is how much? Minus 5 minus x is how much? 0 the whole square plus y1 is how much? Minus 2 minus y is how much? A the whole square is equal to under the root x2. x2 is how much? 3 minus x is 0 the whole square plus y2 is how much? 2 minus y a the whole square. Since both sides square root is there, we can squaring both the side we can do. Squaring both side, what we will get? Minus 5 minus 0 is minus 5 the whole square plus minus 2 minus a minus 2 minus a the whole square is equal to 3 square plus 2 minus a the whole square. Now we need to solve this, children, and let us solve it. Let me rub it here so that I can use the board. What I am having? Minus 5 the whole square, which will be 25 plus this is a minus b the whole square. So a minus b, the a square minus, it will be a square minus 2ab plus b square. So I need to place the value here. A square means minus 2 the whole square minus 2 into a minus 2 into b, a plus b the whole square. B is what? A square is equal to 3 square means 9 plus a minus b the whole square. Again a square means 2 square minus 2 into ab, 2 into a plus a square. So see, children, this is equal, this side of equal is a square, another side of a square. Can I cut this? I can cancel them. So what we are getting with 25 plus 4 minus minus plus 2 2s are 4a equal to 9 plus 4 minus 2 2s are 4a. And now you see, children, this is plus 4 and this is plus 4. I can cancel it, and I can take this 4a this side. 25 is here is equal to minus 4a minus 4a. Minus 4a is already there. 4a will go there. It will become minus 4a. And now see, children, this is 25 and this is minus 4a here. This 4a I shifted here, and this 9. Yes. Now this 9 will go here. Let me write here minus 9. See, I shifted this 9 here because all numbers this side. 25 minus 9 is 16 is equal to minus 8a, and 16 upon minus 8 equal to a. 8 2s are, so a value is equal to minus 2. So here we got coordinate as minus 2. So P coordinates are 0, minus 2. That means our point P is not here. Point P is down somewhere here. So point P will be, this is minus 1, this is minus 2. So point P will be 0, minus 2. Okay, and M will be here and N will be at the top here. And your diagram would be like this. Okay, children? Children, question number 3 of 5.1 exercise. Find the point on the x-axis which is equidistance from minus 3, 4 and 1 minus 4. See, this is y-axis and this is x-axis. So we want to find the point on the x-axis, and that point is equidistance from A and B. A is minus 3, 4. If this is minus 1, this is minus 2, this is minus 3. This is 1, 2, 3, 4. And 1, 2, 3 and 4. 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. So the point is A is minus 3, 4. Minus 3 y-axis 4 means somewhere here. Point A is minus 3 comma 4. Let me write it here. A minus 3 comma 4. This is not the part of the sum. I am just explaining you so that you understand. Point A is minus 3, 4. 1 minus 4. B is 1 minus 4. 1 minus 4 somewhere here. B. 1 comma minus 4. So your points are like this. And you want to find the point on the x-axis. The point can be this side or point can be this side. And that point is equidistance from point A and point B. Okay. So let us see. Let that point be P. Let point on y-axis on x-axis, because that x-axis is P. So if the point is on x-axis, its y coordinate will be 0, children. So P, let it be A comma 0. A is the x coordinate and y coordinate will be 0. Let point on x-axis be P, axis be P, and its y coordinate is going to be 0 because it is on x-axis. And if it is equidistance, PA will be equal to PB, because it is given that point P is at equal distance from A and B. It is given that point P is at equal distance from A and B. So by distance formula, children, by distance formula, PA under the root. Let us assume this as x and this is y. This is x1, this is y1, and this point as x2 and y2. So PA means P will be, can be here or can be that side. If it is here, it will be like this. If it is that side, it will be like this. Okay. So PA, P is xy. So x1 minus x, it will be x1 minus x the whole square plus y1 minus y the whole square, which is equal to under the root x2 minus x1, x2 minus x the whole square plus y2 minus y the whole square. Both are root, so squaring both the side. Squaring both side, we can directly place the value and the root will go x1. What is x1? Minus 3. Minus 3 minus x. X is what? A, the whole square, plus y1. What is y1? Y1 is 4 minus y. What is y? 0. The whole square is equal to x2. What is x2? 1. 1 minus x. What is x? A, the whole square, plus y2. Y2 what? Minus 4 comma y. Y is 0. Minus 0 the whole square. Now minus 3 minus a. That is a minus b the whole square. A minus b the whole square is what? A minus b the whole square will be a square minus 2ab plus b square. So a means what? This is a and this is b. So let us see. Minus 3 square minus 2 into a, that is minus 3 into b, that is a plus a square, plus 4 square means 16 is equal to 1 minus a the whole square, again a minus b the whole square, This is 1 square minus 2 into 1 into a plus a square plus 4 square. Minus 4 square is 16, children. So I think we can cut 16 easily because both are having same sign, and minus 3 square will be 9, minus minus plus 6a plus a square is equal to 1 minus 2 into 1 is 2a minus 2a plus a square. Now I can also cut a square and a square. So I'll shift 2a this side and 9 that side. 1 minus 9 and 9 went that side. There is 6a plus 2a minus 2a is there, children. So minus 2a will come here, it will become plus 2a, and 9 will go that side, it will become minus. 1 is already there, so 1 minus 9 is minus 8. 6a plus 2a is 8a. So 8a is equal to minus 8. So a is equal to minus 8 upon 8 cancels. So a value we get minus 1. So P point we got minus 1 comma 0. So coordinate point P is minus 1, x coordinate, and 0. Where will be minus 1? Minus 1 will be somewhere here. Okay, that means our point should go this way. Fine. Minus 1 comma 0. So point P is here. So PA is equal to PB, and we got the coordinate of point P. You can pause the video, children, and you can solve the sum. Now we will be moving to the next sum. Now children, we have solved example 06. See children, I am solving solved example along with the exercise. So which sum are related to the sums which are in exercise, I am solving prior to those this examples. Okay, separately I have not made video. Earlier I have done it, but now in this I have not done like that. So concept wise I have made. Whatever solved example concepts are related to the exercise, those sums are solved before solving the exercise. Okay, so now we will move to the solved example 6, in which coordinate A, B and C are given, and they are given that they are the vertices of triangle ABC. We have to find the coordinate of circumcenter. Now circumcenter means there is a circle and there is a triangle. A is here, lie on the circle, that is minus 3, minus 4. B is minus 5, comma 0, and C is 3, comma 0. And circumcenter means which lie in the middle exactly of the circle. We want to find the coordinate of that point, that is x and y. So what are the coordinate of point P, that is x coordinate and y coordinate? So if you go to see children, this is the radius. So we can say PA equal to PB equal to PC. So if it is a circumcenter, then PA will be equal to PA, PC will be equal to PB, because radii of the circle, and that we can do by using distance formula. Let us start by distance formula. So PA is equal to, let me take PA square, so I don't need to take that root. Okay, PA, let me find, PA is PA. So if this is x1, y1, this is x2, y2, this is x3, y3, then now we can find out by using distance formula, and this is xy. So PA I want to find out. So x1 minus x, what will come? x1 minus x the whole square plus y1 minus y the whole square. Children, see here I am not using the root. You want, I will use the root, see, like that. Fine. Now if I will square, what will happen? This one also will become square, this one will also become square. Fine. PA is this. So let me take PB. PA is equal to PB. So also write down PB. So what will be the formula for PB? PB. PB is this x2 minus x. Okay. x2 minus x the whole square plus y2 minus y the whole square. Now as we know, radii means PA is equal to PB. So I can equalize them. So I can easily write under root x1 minus x the whole square plus y1 minus y the whole square is equal to x2 minus x the whole square plus y2 minus y the whole square. Now I can take the square root, squaring both the side. If I will square both the side, then this square root will go. Let me write here squaring both side. x1, what is the x1 coordinate? Minus 3. So minus 3 minus x coordinate. X we want to find out the whole square plus y1. y1 is what? 4 minus y is equal to x2. x2 is how much? Minus 5 minus x the whole square plus y2. y2 is what? 0 minus y the whole square. Now this is also whole square. Okay. Now minus 3 minus x the whole square, a minus b the whole square formula. A minus b the whole square will be a square minus 2ab plus b square. So a square means minus 3 square minus 2 into a minus 3 into b x plus x square plus 4 minus y the whole square. Again a minus b. 4 square minus 2 into 4 into y plus y square is equal to minus 5 minus x the whole square. Minus 5 whole square minus 2 into 5 into x plus x square plus minus y the whole square is y square. Now whatever is getting cancelled, let me cancel it. Y square and y square is gone, x square and x square, because see this is plus, this is also plus, and equal is in the middle, therefore they will get cancelled. Y square and this y square also will get cancelled. So minus 3 the whole square is 9. Square is 16 minus 2 4s are 8y, 2 4s are 8y, 8y is equal to minus 5 square is 25 minus 2 5s are 10x, 10x, that's all. Okay, so we got 9, 6x plus 16 minus 8y, 25 minus 10x, and rest of the things are getting cancelled. So all the similar term we will bring together. See here 6x is there, so 10x I will bring here. So it will be 6x plus 10x minus 8y. So I have taken this, I have taken this, I have taken this. Now what is left now? See 25 and 16 is going here, minus 16 and minus 9. Okay. Now 6x plus 10x will be 16x. Let me write here 16x minus 8y is equal to 25 minus 16 and minus 9. Minus 16 and minus 9 will be minus 25. So plus 25 and minus 25 will be 0. So this is your first equation, children. This is your first equation. Now let me get the second equation. Let us rub the board. So by distance formula, we can find out the second equation now. I have written the first equation. And now we got before this PA equal to PB we have taken. Now we will take PA equal to PC. Now we will take PA equal to PC by distance formula. So under the root PA will be minus 3 minus x the whole square plus let me write the formula first. x1 minus x the whole square plus y1 minus y the whole square is equal to PC x3 minus x the whole square plus y3 minus y the whole square. See, I am always taking this number first and then this number first, then this number first, then this. Okay. x1 minus x. What is x1? Now squaring both the sides first. Squaring both sides. So we don't need to write the square root again and again. So x1 is how much, children? Minus 3. Then minus x the whole square plus y1 is how much? 4 minus what? Y the whole square is equal to x3 is 3 minus x the whole square plus y3 is what? 0 minus y the whole square. Now minus 3 minus x, a minus b the whole square formula. A square means minus 3 square minus 2 into a into b plus b square plus 4 minus y the whole square. 4 square minus 2 into 4 into y plus y square is equal to 3 minus x the whole square. 3 square minus 2 into 3 into x plus x square then plus y square. Okay. Now minus 3 square is 9 minus 2 3s are 6x minus will become plus 6x plus x square plus 16 4s are 8 2 4s are 8y minus 8y plus y square is equal to 3 square is 9 minus 2 3s are 6x plus x square plus y square. Now children, see what can be cancelled here. Plus y square will go, plus x square will go, plus 9 will go. Left is what? 6x. Okay, let me write 6x then plus 16 minus 8y is equal to minus 6x only. 3 square 9, 2 3 is 6x plus x square and plus y square. Okay. Now all the similar term I will bring together. This is 6x and this is minus 6x. So 6x plus 6x minus 8y is equal to minus 16. 16 I shifted that side, children. See, this is 6x here. This minus 6 I brought here, it became plus. This minus 8y is here only, this side of the equal. And I am shifting 16 this side, it is minus 16. So 6x is 12x minus 8y is equal to minus 16. This is my second equation. Let me rub the upper part. You can pause the video, children, and you can solve it. If it is easy for me to cancel, let me cancel some of the thing. Now my equation is 12x minus 8y is equal to, see, 12x minus 8y is equal to minus 16. I can divide this equation by 4. See, 4 and 4. What I am getting? 4 3s are 3x minus 4 2s are 2y, 4 4s are. So this is my second equation. Or I don't need to cancel also by 4 because see here I am having 8y. Don't need to do it. Directly we can solve these two equations, simultaneous equation. Now first and second. Okay, let us see. 16x minus 8y is equal to 0. This is my first equation. Operating this two, I will be subtracting first from 2. Subtracting first from 2. See, this is my first, I am subtracting it from second. So this sign will change minus, this sign will be plus. Okay. Now look here. Why did I do that? Because 8y I can cancel. One is minus 8 and one will become plus 8 if only I subtract them. So this get cancelled. 12x minus 16x will be minus 4x. See, from 16 you subtracted 12, you got minus 4x, which is equal to minus 16. Sign of this number is minus 16. So x is equal to minus 16 upon minus 4. 4 4s are. So x is equal to 4. You got x equal to 4. Now place the value of x in any one of the equation. Let us place, children. You can do it yourself also or the other way I am doing it. See. Now let me place the value of x in first equation. Okay. Placing x value in first equation. Value in first equation. What I am getting? First equation is this: 16 into 4 minus 8y is equal to 0. 64, 16 4s are 64 minus 8y is equal to 0. Now let me shift 8y this side. What I'll get? 64 is equal to 8y because minus 8y will become plus 8y. So 64 upon 8 is equal to y. 8 8s are. So I got y value as 8. To check whether my values are correct or not, let me place in one of the equation. Let me place it here and check it. Minus 8 into 8 and 16 into 4. 64 minus 64 0. So my answers are correct, children. My x value is 4 and y value is 8. So I got the coordinate of circumcenter of triangle ABC, that is 4, 8. You can pause, you can rewind and you can solve this sum, children. Practice set 5.1, fourth sum. We have to verify that point P, Q, R are the vertices of a right angle triangle. If it is a right angle triangle and point P, Q, R are the vertices, then in this sum we have to prove that P, Q, R are the vertices of a right angle triangle. Right angle triangle means what? The PR square should be equal to PQ square plus QR square. If it is like this, then we can say it is a right angle triangle. And PR square, how do we get? By distance formula. So by making use of distance formula, we will be proving it. Let us write here, P is minus 2 and 2 and Q is 2, 2 and R is 2, 7. So let me write here x1, y1, x2, y2 and x3, y3. So let us do it, children. First we will find out PR square. So PR is equal to under the root by distance formula, PR x3 minus x1, x3 minus x1 the whole square plus y3 minus y1 the whole square. Place the values here. x3 is 2 minus 2 the whole square plus y3 is 7 minus y1 is 2 the whole square. What are we getting here now? 2 plus 2 the whole square plus 5 the whole square, that is 4 square plus 5 square, which is equal to 16 plus 25 and under the root. So PR is equal to under root 6, 5, 11, carry 1, 41. So PR we got under the root 41, but we want PR square. Squaring both the sides. Squaring both sides, we will be getting PR square is equal to 41. This is our first technique. Let us find PQ square and QR square. So let me find here PQ. PQ again by distance formula. PQ means this and this. So x2 minus x1 by distance formula. x2 minus x1 the whole square plus y2 minus y1 the whole square. What are we getting here? x2 is what? 2 minus minus 2. 2 minus minus 2 the whole square. See 2, this is x2, this is minus, and x1 is how much? Minus 2 plus y2, that is 2 minus y1, y1 is 2 the whole square, which is equal to 2 plus 2 is 4 square plus 0 square, which is equal to under root 16. So we got PQ as under root 16, but we want PQ square. So squaring both the sides, PQ square is equal to 16. Now children, you will think, where is the root gone? When I square this side and this side, both sides, then I get what? PQ square. Root 16 into root 16 is 16. Now let us find for PQ we got QR square. So QR is equal to, by distance formula, Q and R, x3 minus x2, x3 minus x2 the whole square plus y3 minus y2 the whole square. What are we getting? Is x3, x3 is 2 minus x2 is 2 the whole square plus y3 is 7 minus y2 is 2 the whole square. And what we are getting is 0. Under the root we will get 2 minus 2 will be 0 children, plus 7 minus 2 will be 5 square. So QR we are getting, QR is equal to under root 25. But I want QR square. So squaring both the side, I'll get QR square as 25. When I'll square this and this, I'll put square here and also put square here. QR square will be QR square. But under root 25 square will turn into 25. Because 25 under root 25 means under root 25 is 25. So we are getting QR square as 25. Now let me write it here children. We got PR square as 41, and let me add QR square and PQ square. PQ square is how much? PQ square plus QR square. What is PQ square? This is PQ square 16 plus what is QR square? 25, and if we add them we will get 41. And PQ square plus QR square is 41, PR square is 41, both are equal. So we can say PR square is equal to PQ square plus QR square from first and second. And if sum of the perpendicular side, if sum of two side square will be equal to one of the side of a triangle, then by converse of Pythagoras theorem, this is a right angle triangle. So we can write here, therefore by converse of Pythagoras theorem, triangle ABC is a right angled triangle. Right angled triangle. Hence proved children.